Today we're doing weighted averages. The weighted average of M is the sum of the products of the number of units and value per unit divided by the sum of the number of units. What this means is, we add up the product and the value per unit. So let's say the product of the number of units, and let's say the value for this one's 2. This one would be like 3x. This will be 4x. We add that up, and then we divide by the sum of the number of units. The way this works is some teachers do weighted averages. They make your homework worth 25% of your grade. They make tests worth 50% of your grade. They make quizzes worth 10%. All right, that adds up to 100. And then that's how they find the average. Now, that's not how I do it. I do it by total points. But some teachers do it that way. Right? They make tests worth 50%. So they add up all the grades you got on your tests and make that worth 50% of your grade. They add up all the grades you got on your homeworks and make that worth 30% or something like that. All right, so that's all weighted average is. Here's an example of a weighted average. You don't have to write this down, but this is an example. Okay, this is an example I like. This is slugging percentage for baseball. They have a batting average, which they just take how many times a person gets on base versus how many times they're at bat. But what they also do is they also have a slugging percentage. And the reason they do that is because it's pretty common to get on first base. In baseball, if you can get on first base, you're going to do that a lot more than you're going to get for doubles and triples and a home run, right? So what they do is they just take out how many times you get to first base. Let's say it's like 4, all right? Now, you're not going to get a double as very often, so they make it work twice as much as a single. Now, you're going to get a triple even less than you would a double, so they make that triple what a single is. So it's worth more. A home run, right? Someone in baseball might have 40 singles, but they may only have, let's say they have 10 home runs, right? Home runs are worth more. So that's why it's quadruple as many as singles. So that's why 4 times 10, that's the same amount as just singles. So that's how they calculate sluggage, your slugging percentage, based on your at-bats. Okay, you take how many times you get a single, times that, add that to how many times you get a double, triple, home run, and then you divide that by how many times they're at-bat. That's how they find slugging. Okay, this is an example of a weighted average. All right, you don't need to write this down. What you need to do is open your book to page 132. We're going to do example number 1. I think it's just beneficial if you just read it instead of writing this down. All right, what they tell us is a company sells blended tea for $25 a pound. All right, that's this blackberry tea right here at $25 a pound. To make blackberry tea, they use dried blackberries right here that cost $10.50 per pound. And they blend that with their black tea that costs $35 a pound. Okay, so we're wanting to find out how many pounds of black tea should be added to 5 pounds of dried blackberries to make this blended tea, this blackberry tea they have. All right. So what I would do in your homework, I would draw a table like this. All right, and I have dried blackberries. Okay, I'd write my number of pounds. Okay, they tell me 5 pounds of dried blackberries, so that goes here. They tell me that dried blackberries cost $10.50, so my total price is my price times the unit. Okay, how many pounds I'm using. So my price is $10.50 times 5. My blackberry tea, or my black tea, sorry. Right? It says how many pounds of that black tea should be added. So do I know how many pounds of black tea? No, so that's my X. My total price for black tea is 35 times X, right? It's $35 per unit, and I have X number of pounds. My blackberry tea is a combination of the two, so my number of units is going to be 5 plus X, because it's a combination of blackberries and the black tea. It costs $25 per unit, so my total price is 25 times 5 plus X inside parentheses. Now what we can do is we can come up with an equation using this information, all right, to see how many pounds of black tea I need to add the 5 pounds of dried blackberries to make this tea. So I have this. I write down my price of blackberries. I know is my total price on the table, which is $10.50 times 5. What is my price of tea on the table? 35x. And then when you add these, okay, this will give you the price of the blackberry tea, which we found is 25 times 5 plus W. Then what we can do is we can just solve the equation. So I do 1050 times 5, which is 5250. My 35W stays, or 35X stays. I distribute my 25 out. I don't know why I put W, it's supposed to be X, sorry. So 25 times 5 is 125. 25 times X is 25X. Everybody with me so far? Yeah. Now we have to get X on the same side. So I'm going to move the smaller one like I've been doing. So I'm going to subtract 25X to both sides, because I want to keep it positive as much as possible. 35X minus 25X is 10X. Then I'm going to subtract my 5250 to both sides. All right. I want to go ahead and move it over. $125 minus 5250 is 7250. So we have 10x is equal to 7250. So what do I do now? Divide by 10. X is $7.25.
So it's just like what we've been doing?
Exactly what we've been doing, except now it's with weighted averages. Okay? So that is X. Okay? So to make the blackberry tea, 725 pounds, it's not dollars, sorry. 7 and 1/4 pounds would be used to make the black tea. Okay? So that's how much you would add to the blackberries. Any questions? All right, so on page 133, we're going to do the coffee example now. It says, how many pounds of premium coffee beans should be mixed with 2 pounds of supreme coffee beans to make the blended coffee? So what I do is I set up my table. I have my premium, I have my supreme, I have my blended. My number of pounds, I don't know how many pounds I need for premium, right? That's what's asking for, so that's my X. It says it is $9.50 for the premium blend. So my total price is $9.50 times X. My supreme blend, how many pounds of that do I need? 2. So I take $11.75 times 2. So I'm going to go ahead and work that out since I already know it. Okay. It is $23.50. And then my blended, how many pounds of that do I need? Okay, that is a combination of the premium and supreme, right? Yeah. How many pounds of premium do I have?
2.
Premium. X. Right, and then how many supreme? 2. So we add them. All right, and then my total price for that is 10 times X plus 2. Now I make my equation, right? I have my total price for premium, which is $9.50x. I add that to my $23.50 for my supreme, and that gives me a total of 10x plus 2. So these 9.5x plus 23.5 is going to add to 10 times x plus 2. So we distribute that out. 10 times x is 10x. 10 times 2 is 20. Now I want to get x on the same side, so I'm going to move my smaller one. I'm going to subtract 9.5x to both sides. And in the same step, I'm going to subtract 20. I'm going to move it over there so I can get x by itself. So over here I have 3.5 is equal to 0.5x. So I divide both of these by 0.5. Dividing by 0.5 is the same thing as timesing by 2. Okay, you can do it on a calculator and prove that for yourself. X is 7, meaning we need 7 pounds of premium to mix with 2 pounds of supreme. So there's my answer, 7 pounds. All right, let's look at example 2. It's on page 133. This is the percent mixture problems. You're going to see a couple of these in your homework. All right. It says Mrs. Matthews has 16 cups of punch that is 3% pineapple. She also has a punch that is 33% pineapple. How many cups of the 33% punch will she need to add to the 3% punch to obtain a punch that is 20% pineapple juice?
16.
Okay. So, X is going to be the amount of 33% solution that we need to know. Okay, because that says how many cups of that do we need. So I don't know how much of that. Right? That's why it's my X. How many cups? The amount of punches in cups. How many cups of the 3% do I need? 16. And then what about the 20% punch? How many cups is that going to be? 16 plus X. Okay, because it's the 16 cups of 3% plus the X amount of 33%. When we add those, right, the 3% is a lot less of punch than the 33%. So it's going to bring down the percentage, right? It's going to water it down, so to speak. So when we're trying to find a 20% ratio. My amount of pineapple juice, what we do is we take the percentage times the cups. So 3% is 0.03 times 16. My 33% is the same thing as 0.33x. And then my 20% is 0.2 times 16 plus x. All right, everybody with me so far? All right, so then we come to an equation. I need my amount of pineapple juice, which is 0.03 times 16, which I will work on a calculator. 0.03 times 16 is 0.48, plus my 33%, which is 0.33x. That will give me my amount of juice for the 20%, which is 0.2 times 16 plus x. So now what do I need to do? Distribute the 0.2. 0.2 times 16, that is 3.2. And then 0.2 times x is 0.2x. So I drop all that down. 0.48 plus 0.33x. Now what do I want to do? I want to get x on the same side. So I subtract the smaller one. I'm going to subtract 0.2x. 0.33 minus 0.2 is 0.13x. I'm also in the same step to save room. I'm going to subtract 0.48 to both sides. So my point, and then I'm going to erase this, guys. You have it written down? Because I got to make some room. Okay. All right. So I'm going to erase what we got right here. All right. So we have 0.13x is equal to, it was 3.2 minus 0.48. So we have 2.72. Now what do I need to do? Divide by 0.13. Okay, x is equal to 20.9. And this is what? Is it cups, pounds, percentage? What is this? Cups, right? So this is how many cups of the 33% that I need. All right, now we're going to do the example 3, which is on page 134. Okay, this is uniform motion problems. All right, also known as rate problems, and they're problems in which an object moves at a certain speed or rate. What you need to know is this formula right here: distance equals rate times time. Okay, I will call it as D equals RT all year long. If you are confused by it, think about it. If I go 50 miles an hour for 2 hours, how far did I go? 100, right? 50 miles an hour, 2 hours, 50 times 2 is 100. Okay, so that is D equals RT. Distance equals rate times time. So on page 134, it said it took Travis and Tony 40 minutes to skate 5 miles. That says the return trip took them 30 minutes. What was their average speed for the trip? So what we need to do is we need to find the average speed for going and the average speed for the return. Okay, so for going, okay, if I know my distance, right, 5 miles, I don't know my rate, right, that's what I have to find, but I know my time, which was what? 40 minutes, which I would want to change the hours because we're talking about miles per hour. So I would take 40 divided by 60, okay, and that would give you 0.667 hours. So my x here, my rate, we could call it, right, is 5 times 0.667 because we have to get it to the other side, okay, to get x by itself. Yeah. Oh no, hold on. Sorry, I got this all wrong. Okay, we shouldn't have been dividing. We should have been multiplying because my rate times my time. My time was 0.667. So I divide by 0.667, sorry. So 5 divided by 0.667, okay, comes out to 7.5 miles per hour. That was their average speed going. So let's do the return trip. My return trip, okay, we can do it as D equals RT. My distance, did it change? No, they're still going 5, right? What's my rate? That's what I don't know, right? So this is my rate for return. My time was 30 minutes, which how much of that is an hour? Half, so 0.5. Right? So to find my rate, I divide both sides by 0.5. So my rate return is 10 miles per hour. So then what I do is I take a weighted average of those two. So I take my speed, which is 7.5, and I times it by the time, all right, which I'm going to go to the other page so you can see it. This is going to be the weighted average. All right, this is something you should write down for the trip. This is how we find the weighted average. All right, so now we can go ahead and fill this out. The rate of going, that's what we found earlier. That's 7.5 miles per hour. How long did they travel at this rate? 40 minutes, right? Or 0.667 of an hour. We add that to the rate of the return. How fast do they go coming back? What did we find? 10 miles per hour. And how long did they travel at this? 30 minutes, which is 0.5 of an hour. And then what we do is we divide by the time of going plus the time of return. The total amount of the trip, which would be what? Okay, 70 minutes, which is the same as 1.167 hours. Okay, you add the 0.667 and the 0.5. This is how we find weighted average. Okay, if you were finding normal average, right, if we just take 7.5 plus 10, divide by how long they traveled, right? But one rate, they went faster on the coming home, but they didn't go as long, right? They only went half an hour. They went slower, so it took them longer. That's why we have to find a weighted average. Okay, what's their average speed? So we go ahead and add all this up. 7.5 times 0.667 plus 10 times 0.5. That gives you a total of 10.0025 over 1.167. When you divide by that, that tells me my average speed was 8.6 miles per hour. They were going faster on the way home, but they didn't stay that rate for as long. So that's why you don't get as much, right? And then 7.5, they went slower, but they traveled for that longer. So that's weighted heavier. All right, any questions? All right, let's look at example 4. And that's on page 135. All right, just look at it. You don't have to write it down. It says 2 trains are 550 miles apart heading toward each other on parallel tracks. Train A is traveling east at 35 miles an hour, while train B travels west at 45 miles an hour. When will the trains pass each other? So we want to find out when they're going to meet. Now, are they going to meet in the middle? No, one's traveling faster than the other, right? So they're not going to meet in the middle. So we're going to find out, okay, when will they pass? So T is going to be the number of hours until the trains pass each other. My R is my rate. So how fast was train A going? 35 miles an hour. Okay, train B was traveling at 45 miles an hour. Okay, T is the same for both because it's the same amount of time. We need to find the distance they traveled. So 35 times T, right? And train B was 45T. So then we set an equation. Train A is traveling at 35 miles an hour for T amount of time. Hey, it could be an hour, it could be 3 hours. Train B is traveling 45 miles and at that same amount of time. Okay, and this equals 550 because that's how far apart they are. So we need to find T when they equal each other. So we need to find T when they pass. So what I do is I add like terms. 35T plus 45T is 80T. We divide both sides by 80. We can get rid of the 10. 55 divided by 8. T equals 6.875 hours. So at about 7 hours, that's when they'll cross. All right, does that make sense? Any questions? All right, this is your assignment. You need to write this down.